Hello and welcome to this session on statistics. In this session, we are going to discuss about chi-square test. So before understanding chi-square test, let's understand few of the important terms. So first one is parameter. So we already have seen like these terms earlier, like while we had introduction to statistics. So parameter defines the characteristic of a population. So a parameter in statistics refers to an aspect of a population, as opposed to statistic, which refers to an aspect with respect to sample. So we say sample characteristic is nothing but it's called as statistic, and population characteristic is called as parameter. So for example, population mean, so that is a parameter. Standard deviation of population, that is a parameter. So now what is a parametric test? So there is something called as parametric test and non-parametric test. So parametric test or a parametric statistical test makes an assumption about the population parameters and the distribution that the data came from. So here basically this is some kind of test which can make some assumption about the population parameter, like the average of population data or the standard deviation of population data and so on. So these types of test includes student's t-test and ANOVA test, which assume data is from a normal distribution. So we have already seen this test, that is we have done hypothesis testing, and in hypothesis testing we have seen student t-test or t-test as well as ANOVA test. So this test fall under parametric test, and this test also follows a normal distribution. The other one is non-parametric test. A non-parametric test don't require that your data follow the normal distribution. They are also called as distribution free test. So it doesn't need your data to be normally distributed. And this is also known as distribution free test. So now chi-square test is a non-parametric test. So that means the data does not need to be in normal distribution in this case. So chi-square test is a non-parametric test which is commonly used for testing relationships between categorical variables. Now to understand categorical variables, we can use this test, that is chi-square test. Chi-square test is denoted by a Greek letter, that is x square. So that is chi-square we can say here. So it's a Greek letter uh, chi-square. This is developed by Carl Pearson. So it was developed around 1900 by Carl Pearson. So few important characteristics of this test are: this test as a non-parametric test is based on frequencies and not on parameters like mean or standard deviation. So here we are not going to use parameters like mean, standard deviation. This test is based on frequency of the data, which is the count of the variables, values and all. This test is used for testing the hypothesis and is not useful for estimation. This is not useful for estimation. This test can also be applied to a complex contingency table with several classes, and as such is a very useful test in research work. So if we have multiple categorical variables, we can just put it in a contingency table, which is nothing but a frequency table, a two-way frequency table, and we can use this kind of test on top of those tables to understand the data, to understand the relationship between those variables. This test is an important non-parametric test as no rigid assumptions are necessary in regard to the type of population. No need of parameter values and relatively less mathematical details are involved here. Chi-square test also follows a distribution which is called as chi-square distribution. So here suppose if x1, x2, xn are independent normal variates. So we have some normal variables here, independent variables. Those are like x1, x2, x3 till xn, and are independent normal variates, and each is distributed normally with mean 0 and standard deviation unity. So here mean is 0 and unity standard deviation is there. That is, one is 0, the other one is 1, the third one is 2, like that. So then it will be x1 square plus x2 square plus till xn square equals to summation of xi square. So we can also write it as summation of xi square, where I is nothing but the number of variates. So this is distributed as chi square with n degrees of freedom, where n is large. So here it has n degree of freedom. So the chi-square curve for degree of freedom n equal to 1 and 2 and 3 and 5 and 10 is as follows. So you can see a figure here which shows if the degree of freedom is 1, how does it look like? If degree of freedom is 2, for degree of freedom 3, 5 and 10. So this is how chi-square distribution looks like. Now few of the applications of chi-square test. So where all we can apply this chi-square test and what kind of insights can we get from the data? So first one is goodness of fit test. So this test enables us to see how well does the assumed theoretical distribution such as binomial, Poisson, normal distribution fit to the observed data. So now we have a few data. Now here we can just see like with respect to our data it fits which kind of distribution and to what extent does it fit, or how well does the distribution fit. So that's what we can also see here, that is goodness of fit test. The other one is, this is the most commonly used chi-square test application, that is test of independence. This test enables us to explain whether or not two attributes are associated with one another. So this is one of the most important tests, like where we can find out the relationship between the categorical variables. So usually for finding out the relationships or the association between continuous variables, we have something called as Pearson's correlation coefficient. And here for testing out the categorical variable relationship, we can use Pearson's chi-square test. This is also called as Pearson's chi-square test because it is created by Karl Pearson. It is developed by Karl Pearson. The other application here is test of homogeneity. This test can be used to test whether the occurrence of events follow uniformity or not. For example, the admission of patients in government hospital in all days of a week, use uniform or not, can be tested with help of chi-square test. So we can also test the homogeneity, that is the occurrence of some event follow uniformity or not. So these are certain applications of chi-square test. Now the formula behind chi-square test is given as chi-square equals summation of O minus E whole square divided by E, where O is nothing but the observed frequency and E is the expected frequency. So the steps involved for testing a chi-square test. So we'll take the example of test of independence, that is the most commonly used one, and we'll see what are the steps involved to test this test of independence or test of association also you can say. So first thing is we have to determine the hypothesis. So here null hypothesis would be variables are independent. So by default null hypothesis says that the variables are independent. Alternate hypothesis would be variables are associated. So alternate would be they are associated. So here first like we have to determine the hypothesis. After that the next step is to calculate expected frequency. So we know observed frequency is nothing but it is the count of the categorical value, and expected frequency would be E equals row total into column total divided by grand total. So we have to take the grand total. First we have to multiply row total with column total divided by grand total. That will give us the expected frequency. After we get the expected frequency, we can just find out the test statistic. We can calculate the test statistic, that is nothing but the chi-square, which is given by summation of O minus E whole square divided by E. So that is observed frequency minus expected frequency whole square divided by expected frequency. Then we can determine the degree of freedom. Degree of freedom is given as R minus 1 and C minus 1, multiplication of that. R is nothing but number of labels in a row and C is number of labels in a column. So after degrees of freedom, we also have to actually find out this one, that is level of significance. We have to set a level of significance. By default, level of significance is taken as 0.05, that is 5%, 0.05%. Then what we have to do is we have to find out the critical value. So once we get the level of significance and once we get the degree of freedom, we have to find out the critical value or the table value for chi-square. So chi-square also has a distribution, chi-square distribution. So it has a table which will give us the critical value. So if our calculated value is greater than the critical value, then we will reject the null hypothesis. So once we get the table value, then we have to compare the table value with the calculated value, like which we are calculating by using the formula x square equal to summation of O minus E whole square by E. So if our calculated value is greater than the critical value, then we will reject the null hypothesis. Then we will say that the two variables are associated with one another. So more the chi-square value, the association also would be better. So now here to take an example and to understand this, presume you observe 100 people to see who deposit garbage in the can and who litters. So you want to see if there is a difference between gender. So now we have to find out like who is actually depositing the garbage in the can and who is littering the garbage. So here like we have to compare if there is any difference with respect to gender. So a person can fall under one of the following four categories here. One is male deposit garbage, or the second one is male litters. The other one is female deposits garbage, and the last one is female litters. So now this is our data we have got. Like it says deposit female is 18 and 7 females have littered. And for male, it shows 42 male deposited garbage and 33 male littered. So now this is our data. Now these are nothing but our observed frequencies. We have to find out the expected frequency here. So if the data is in categorical column, like categorical values, we can find out the frequency table. This is nothing but a frequency table which shows the frequency of each of the data. So this we can say as observed frequency. Now the next one is we have to find out the expected frequency. So here first we'll define the null hypothesis and alternate hypothesis. So null hypothesis would say no relation between gender and garbage deposit, they are independent, and alternate will say they are associated. That is, relationship is there between gender and garbage deposit. So we have to find out if there is any relation with respect to depositing garbage in can and gender. So does gender matter with respect to depositing garbage in can? So we can put this nominal data. So this data is nothing but nominal data in 2x2 contingency table. So here when we put it in contingency table, we can just get the count of each of the column as well as row. So we are getting the total for female is 25 and male is 75, and similarly total for deposit is 60 and litter is 40, and the total number of record is 100 here. So first we have to find out the expected value here, that is row total into column total divided by the total. So we have to first find out row total, that is row total by column total divided by the total. So now here we have to do this, and then we will be calculating the chi-square value by using the chi-square formula. So now let's find out the expected values. So here expected value would be like for the first one it is 18, so we have to take row total. Row total is nothing but 25. So first to find out this 15, like how did you get this 15? 15 is the expected value here. So now to get this, we know the expected value formula is row total into column total divided by the grand total. So row total is 25 and the column total here is 60. So we can see the row total is 25 and the column total is 60. So that will be row total into column total, that is 25 into 60 divided by, we have to take the grand total. So grand total is nothing but here it is 100. So it will give us 25 cross 60 would be 1500 divided by 100, which is nothing but 15. Similarly, we have to find out for all the other columns. So once we get the expected values, these all red ones are expected values. So once we get the expected values, then we can calculate the chi-square. Chi-square is given by summation of observed value minus expected whole square by expected value. So we can say the observed value is 18 for the first one minus expected value for that is 15 whole square divided by 15. Plus the second one is 7 minus 10 whole square divided by 10. Third one is 42 minus 45 whole square divided by 45, and fourth one is 33 minus 30 whole square divided by 30. So this is giving us value as 2.0. So once we compute this, we'll be getting the chi-square value as 2.0. Now we have got the chi-square value. So now let's calculate the degree of freedom for this. So degree of freedom is given as number of row minus 1 and number of column minus 1. So number of rows we have is 2 rows and 2 columns. So it will be 2 minus 1 into 2 minus 1, where we are getting a degree of freedom of 1. And let's set the significance level as 0.05. So we can take any significance level, but here basically like based on the problem statement, we have to actually figure out what should be the significance level. By default, it can be taken as 0.05. So here we will take significance level as 0.05. Now we have to find out the critical value from the table. So we have to look into chi-square table to find out this value. So here we have a chi-square distribution table. In this we can see for degree of freedom 1 and for a level of significance as 0.05, we have a chi-square value of 3.841. So this 3.841 is our table chi-square value or the critical value. So now here we got the critical value as 3.841. So here as the calculated value, that is chi-square value, is lower than the critical value. So our calculated value is 2.0, which is lower than critical value. So we cannot reject the null hypothesis. We already have seen earlier that if the calculated value is greater than the critical value, then only we can reject the null hypothesis. But our calculated value is lower, so we cannot reject the null hypothesis. So null hypothesis says there is no relationship between gender and garbage deposit. So we can also conclude that it is true. So there is no relation between gender and garbage deposit. So this is how we can do a chi-square test. So now we'll see a case study with respect to chi-square test by taking Python. Like we'll be implementing a case study in Python, and we'll see how to implement chi-square test in Python. So now we'll see chi-square test in Python, how to implement chi-square test. So basically we'll see chi-square test, that is test of independence case study. So we'll look into test of independence in chi-square test. So now first we'll be importing the packages, that is NumPy and Pandas, the basic packages in Python. Then next is we'll be reading the data set here, diamond.csv. So this is the data, we'll be just converting it to data frame by using pd.read_csv. So here it shows df.sep shows that there are 53,940 records. This many rows are there and 10 columns are there. So now to look into the data set, we have all these columns, that is caret, cut, color, clarity, depth, table, price, X, Y and Z. Now this is a data set collected from a manufacturer of diamonds. So it shows different characteristic of a diamond. Like first diamond is of 0.23 carat, and there is it is of ideal cut. The color is E, clarity is Si2, depth is 61.5. So like that it shows few details with respect to each of the diamond. Now suppose here we want to find out if there is any sort of relationship between clarity and color. So if clarity and color has any kind of relationship among them. So to find out that, we can use chi-square test here. For both of these data are categorical. We have color as E, I like that. So we'll just see what all unique values are there. So we can just use pd.unique, that is pandas dot unique function, to see what are the unique values in this color variable, that is the color column. So it shows the unique values are E, I, J, H, F, G, D. So these are the color values. Similarly, if we look at the clarity, it shows these are the color like clarity values. So we can say out of 53,000 record, these are the unique ones, and it is nothing but categorical column. Both of these columns are categorical. Now here, to see the count, to get the frequency of both the data, we can create a two-way frequency table. It's also called as contingency table. To create a frequency table, we can use pd.crosstab, pandas.crosstab function, and we can just pass here clarity and color. Index is clarity and column is color. So once we run that, it shows that the color in column, that is the row values are actually color counts and the column values are color. So now here clarity is actually row, color is column. So color, it shows D, F, G, H, I, J, and clarity also it shows here on the row. So here we can say clarity L1 and color D. There are 42 records. So the frequency is 42. That is the count. So now for color D and L1, 42 records. For color E and L1 clarity, 102 records. For color F and L1 clarity, 143 records, like that. To get the margin, that is the total of the record, we can also pass one extra argument here saying margin. It will show us the total count. So it says count for the entire row, that is nothing but the clarity L1 is 741. So out of 53,941 records, we have total L1 clarity values, that is 741. Similarly, it shows the count with respect to columns also at the bottom, that is for color D, the total count is 6775. So these are the total frequencies. So now here, to find out if there is any kind of association among these two variables, or if these two variables are independent, that is clarity and color, we can perform chi-square test. Now to perform chi-square test in Python, we can use this package SciPy. SciPy stands for Scientific Python. In that there is a module called as stats. So this stats module has got a class called as chi2contingency, and we can use it to do chi-square test. So this chi2contingency takes the input, that is the argument, as a contingency table, and it will give us the value with respect to the chi-square value, test statistic value, degree of freedom, and the p-value. So here, to do this test, we can just call this class chi2_contingency. Then here we are passing the contingency table. So contingency table is pd.crosstab of clarity and color. And here I am saying at the end that 0:3. So whatever data it will give, I am just picking index value 0 till value 3. So 3 values it will give us out of the result. So once we run it, we can see certain values like this first value 2047.079. This is nothing but this is the test statistic value, that is the chi-square value. So here we are getting the test statistic value as 2047, and the other value here, the next one is the p-value. So here we have a p-value of 0.0 and degree of freedom of 42. We have a degree of freedom of 42. We can look into the contingency, we can look into this chi-square critical value. We can find out the chi-square critical value by looking at the chi-square table, or we can just compare the p-value with the significance value. So here also this test gives us p-value. So now we already know that if p-value is less than alpha, that is the significance value, we can reject the null hypothesis. So here we can see that our p-value is less than alpha, that is 0.05. Suppose we take alpha is 0.05, then p-value is less than alpha. So we can reject the null. So what is null hypothesis here? So we already have seen that in chi-square test, null hypothesis says that the variables are independent. That means there is no significant relationship between the variables. Alternate hypothesis says that they are associated. That is, there is some significant relationship between the variables. So as our p-value is less than 0.05, that is alpha, we can reject the null hypothesis and we can go with alternate. So we can say there is some significant relationship between the variables. Hence, there is some relationship between clarity and color. So both of these variables are associated with one another. They have some sort of relationship. So this is how we can do a chi-square test in Python. So this is all for this session. Thank you for attending.